Good evening, welcome to my channel. This is Obro, and I'm going to start a new topic today regarding the power system. Power system, we all know, it starts with the generation of electricity, transmission and distribution. So in the generation, we know that the electricity is generated in the thermal power plant, nuclear power plant or hydroelectric power plant, and that electricity is stepped up and then it is ready for the transmission system, and then when it goes to the distribution, so the electricity, the voltage is reduced using the step down transformer, and then it is ready for the distribution. So here we are going to start regarding the power system analysis. I have brought one numerical from the power system analysis, and which is the part of a transmission system. And so transmission system, you know that when the electricity is generated, it is ready for the transmission through the electrical power lines in the top tower. So here we are going to start here with the one numericals of the power system analysis. So the numerical is like that find the capacitance and capacitive reactance for 1 mi of the line if the length of the line is 175 mi and the normal operating voltage is 220 kilovolt. Find the reactance to neutral for the entire length of the line, the charging current for mile and the total charging megavolt amperes. So we have to find the charging current for the miles and the total charging megavolt ampere. So here we have found the radius is calculated. This data will be generally given in the questions. So that is 1.108 divided by 2 into 12 is equal to, if we calculate it, we'll get as 0.0962 feet. And D equivalent, that is the diameter, this is the diameter of the wire. And so the diameter of the wire will be, that is 24.8 feet, 24.8 feet. So this is the diameter of this wire. So when we are, we have to find the capacitance Cn. So Cn formula we know, I'm writing over here, that is 2 pi into K divided by Ln D equivalent by R. So this is the formula we are using for calculating the capacitance, that is 2 pi into K. K is nothing but the constant. Ln D equivalent, this is the diameter equivalent by the radius, and this is logarithm of this value. So here we just put the values over this formula, that is 2 into pi. We will take pi, we will take the pi value as 3.14 instead of taking as 22 by 7, and we will put this formula, and K is the constant, that is 8.85 into 10 to the power minus 12 divided by Ln 24 by 0.8, that is the D equivalent, and by R, that is 0.962 feet. So when we are calculating, we are getting as 8.8466 into 10 to the power minus 12 farad per meter. And so we'll go to the next part of the numericals, that is Xc dash. Xc dash we'll get from the table, that is 0.0912 into 10 to the power 6, and Xd dash is equal to 0.0953 into 10 to the power 6. So these two value we'll be getting from the table, and then we will just add up these two values into Xc, that is the reactance, that is 0.0912 plus 0.0953 into 10 to the power 6. We'll get the resultant value as 0.1865 into 10 to the power 6 ohm Mi to neutral. So here we are getting the question that to find the, if the length of the wire is 175 Mi, that is the length of the wire, and the normal operating voltage is 220 kilovolt. So in this case, we have to just divide this value. This is for the whole resistance for the whole wire. So we will just calculate for the 175 length of the wire Mi. So we are just dividing this value as 0.1865 into 10 to the power 6 divided by 175. So if we just divide, we will get as 1066 ohm Mi to neutral. So now we have to find the charging current. What is the charging current? So we know I is equal to V by R is a general formula we studied in our school days. So if we study the power system analysis, we'll get as 220 kilovolt. So we are transforming the kilovolt to volt. So we are multiplying it to 1000. So it is 2,20,000 divided by root 3. So why we are dividing by root 3? Because it is a three-phase wire. So three-phase supply is going, so it is root 3 into 1 by XC, that is the reactance. So we will just put this value XC what we have calculated over here. So 2,20,000 divided by root 3 into 0 divided by 0.1865, and we are putting this 6 to in the numerator, so we are making as -6. So if we just full calculate this whole value using the scientific calculator, we'll get as 0.681 ampere per mi. So now this length of the wire is 175 meter. So we'll just multiply 175 into 0.681. We'll get total current as 119 ampere. So now we will just calculate the reactive power. Reactive power formula is Q is equal to root 3 because it's a three-phase. It is a three-phase wire, so we are calculating into root 3 into 220 into 119, that is the current, into 10 to the power minus 3. So if we calculate whole, we will get as 43.5 megavolt ampere. So we are getting the total current and the charging current, and as well as the total charging megavolt ampere. So I hope you have understood this over numerical, how it works, how we can do the power system analysis. And so this is one of the numericals which is very much important for wherever you go for the examination point of view, in selection test, everything for the electrical part. So this is very much important electrical engineering for if you go for the energy subjects, electrical subjects, these numericals, it will be the same, only they may change the values of the numericals, and the these numericals, these formulas and the process will be same. So I hope you like my videos. So I will end over here, and I will continue my next class in the next video. Thank you very much.